Hi friends, today I am giving a lecture on graph coloring problem. So graph coloring problem is one of the applications of dynamic programming. So the dynamic programming is one of the algorithm design technique. This technique is used for solving optimization problem. So here the optimization may require either maximum result or minimum result. It depends on the given problem. So here the graph coloring problem may require minimum result, that is minimum number of colors required to color all the vertices of the given graph. Now we are discussing about graph coloring problem. So what is graph coloring problem? So here let us consider G is equal to V comma E is a graph where V is nothing but set of vertices and capital E is nothing but set of edges. Here the problem is to color all the vertices of the given graph exactly with the minimum number of colors. No two adjacent vertices have the same color. So this is the graph coloring problem. Once again I am telling. So let us consider a given graph. So in that given graph there are n number of vertices are there. E number of edges are there. Our problem is to color all the vertices of the given graph and no two vertices have the same color. So this is the constraint of the given problem. So let us take one example. So this is a given graph. In this given graph, G is equal to V comma E, where V is equal to A, B, C, D, E, and E is A comma B, B comma E, D comma E, A comma C, C comma D, B comma C, and A comma E. So here our graph coloring problem is to color all the vertices of the given graph, and the constraint is no two vertices have the same color. No two adjacent vertices have the same color. Suppose next, consider the given graph. So there are 5 vertices are there, A, B, C, D, E. Suppose for vertex A we are applying the red color. The same red color cannot be used for vertex B, vertex E, and vertex C because B, C, E are adjacent to vertex A. So for this vertex we have to use different color. But D is not adjacent to vertex A. So we are using the same color for vertex D because A and D, vertex A and vertex D are not adjacent. So we are using the same color for vertex A and vertex D. Next, for vertex B we are using blue color. So the same blue color cannot be used for vertex A, vertex E, and vertex C because A, C, E are adjacent to vertex B. So for these vertices we are not using this blue color. But vertex A has red color, no problem. And vertex E and vertex C we are not use the blue color for these 2 vertices. Next, for vertex C we are using yellow color. Next, vertex E is not adjacent to vertex C. So we are use the same color for vertex E. So vertex C and vertex E are not adjacent. So we are using the same color. So all these vertices are filled with 3 colors. So check once any 2 adjacent vertices have the same color or not. Any 2 adjacent vertices does not have the same color. Check once. Vertex A and vertex B. These 2 are adjacent. We are not use the same color. Next, vertex B and vertex E are adjacent. So these 2 vertices does not use the same color. Vertex D and vertex E are adjacent. So these 2 vertices does not use the same color. Vertex C and vertex B are adjacent. So we are not use the same color for vertex B and vertex C. Vertex A and vertex C does not use the same color because they are adjacent. Next, vertex A and vertex E. So both vertices have the different colors. So these are the adjacent vertices. So does not use the same color. So after the constraint is satisfied, how many number of colors we are used to color all the vertices of the given graph? So there are 3 colors are used. 3 colors. So red, yellow, blue. So 3 colors are required to color all the vertices of the given graph with the constraint that no 2 adjacent vertices have the same color. Next. So the graph coloring problem has 2 versions. The first problem is M colorability decision problem. Second problem is M colorability optimization problem. First, what is decision problem? So the decision problem is nothing but for a given problem, so the answer is either yes or no, then it can be called as decision problem. So here M colorability decision problem is nothing but, so in this problem we have to check whether all the vertices of the given graph can be colored with the M colors or not. M colors or not. So where M is a positive integer, so by using these M number of colors, we have to check whether all the vertices of the given graph can be colored or not. So that problem is called as M colorability decision problem. Next, second one is M colorability optimization problem. So optimization problem is nothing but the problem that may require either maximum result or minimum result. So in this graph coloring problem, we have to use minimum result. Here minimum result is nothing but minimum number of colors. Minimum number of colors used to color all the vertices of the given graph with the constraint that no 2 adjacent vertices have the same color. So here M number of colors we have to use to color all the vertices of the given graph. So we have to minimize the minimum number of colors to color all the vertices of the given graph with the constraint that no 2 adjacent vertices have the same color. So that optimization is called M colorability optimization problem. We have to optimize the M value. We have to optimize the M value. M is nothing but it is a positive number. So minimum number of colors we have to require to color all the vertices of the given graph can be called as M colorability optimization problem. Next we go for chromatic number. So chromatic number is nothing but the minimum number of colors we are required to color all the vertices of the given graph with the constraint that no two adjacent vertices have the same color. So that number is called as chromatic number. Chromatic number is nothing but the minimum number of colors we are required to color all the vertices of the given graph. So that is called as chromatic number of the given graph. Suppose we can take this graph. So this graph contains 4 vertices. So A, B, C, D. So what is the chromatic number for this graph? So that is minimum, how many minimum number of colors used to color all the vertices of the given graph. Suppose for vertex A, we are using the red color. Okay. So the same red color cannot be used for vertex B, vertex C, vertex D because A is adjacent to vertex B, vertex C and vertex D. So the same color cannot be used for these remaining vertices. Next, for vertex B, we have used the blue color. So the same blue color cannot be used for A, D, C vertices because B is adjacent to vertex A, vertex D and vertex C. Next, for vertex C, we are using the yellow color. So the same yellow color cannot be used for vertex A, vertex B and vertex D because C is adjacent to vertex A, vertex B, vertex D are adjacent to capital vertex C. Next, for vertex D, we are use the green color. So the same green color cannot be used for vertex A, vertex B, vertex C because vertex A, vertex B, vertex C are adjacent to vertex D. So we are use 4 colors. 4 colors are required to color all the vertices of the given graph. Check whether the condition is satisfied or not. So A and B are adjacent. So these 2 vertices does not use the same color. Next, B and C are adjacent. These 2 vertices does not use the same color. C and D are adjacent. So these 2 vertices does not use the same color. A and D are adjacent. These 2 vertices does not use the same color. A and C are adjacent. These 2 vertices does not use the same color. B and D are adjacent. These 2 vertices does not use the same color. So chromatic number is denoted by M. So M is equal to 4. 4 colors are required to color all the vertices of the given graph. Then it can be called as 4 coloring problem. So 4 coloring problem is nothing but 4 colors are required to color all the vertices of the given graph. Suppose M is equal to 2. So then it can be called as a 2 coloring problem. So M is equal to N, then it is called as a M coloring problem. Next, suppose we can take a graph. So for this graph, the degree of the graph is denoted by small d. Degree of the graph is denoted by small d. How many number of colors required to color all the vertices of the given graph? That is, d plus 1 colors are required to color all the vertices of the given graph. So where d is the degree of the given graph. So how many number of colors we are required to color all the vertices of the given graph? That is, d plus 1 colors are required to color all the vertices of the given graph. So check, this is one example graph. So suppose this the degree of this graph D is equal to 2. So how can you say that the degree of the given graph is 2? So vertex A, is adjacent to vertex B and vertex C. So how many number of outgoing edges from vertex A? So that is, this is one edge and this is one edge. That is, degree of vertex A is 2. Next, for vertex C, what is the degree? So how many number of edges outgoing from vertex C? That is, so this is one edge, this is another edge. So degree of vertex C is 2. Next, for vertex B, what is the degree of that vertex? So how many number of edges outgoing from vertex B? That is degree 2. Any graph contains, so any graph contains same degree for all the vertices. So then it can be called as a degree of the given graph. So for this graph, degree of the given graph D is equal to 2. How many number of colors we are used to color all the vertices of the given graph? So D plus 1 color. So D plus 1, that is equal to 2 plus 1. That is 3 colors are required to color all the vertices of the given graph. Check. First, for vertex A, we are using the red color. The same red color cannot be used for vertex B and vertex C, because vertex B and vertex C are adjacent to vertex A. So we are not use the same color. Next, we are using the blue color for vertex B. So vertex A and vertex C are not use the same color, because so A and C are adjacent to vertex B. Next, for vertex C, we are using yellow color. So vertex A and vertex B are adjacent to so vertex C. So these two vertices does not use the same color. So check any two adjacent vertices have the same color or not. So by considering vertex A and vertex B, these two vertices does not use the same color. Condition satisfied. Vertex B and vertex C, these two vertices does not use the same color. So condition is satisfied. Vertex A and vertex C, these two vertices does not use the same color. So condition is satisfied. So how many number of colors we are used to color all the vertices of the given graph? That is equal to M is equal to 3 colors. Suppose consider this graph. How many number of colors we are used to color all the vertices of the given graph? So degree of each vertex in this given graph is equal to 4. So D is equal to 4. So for vertex A, how many number of outgoing edges for vertex A? That is 4 vertices, 4 edges, 4 outgoing edges. So degree of A is equal to 4. For vertex B, degree 4. For vertex D, degree 4. For vertex C, degree 4. For vertex E, degree 4. So how many number of colors we are used? D plus 1, that is 4 plus 1, that is 5. So M is equal to 5. 5 colors are required to color all the vertices of the given graph. Next, suppose we can take a complete graph. Complete graph is nothing but, in the given graph, we can take any pair of vertices. That pair of vertices are connected by using a edge. So that graph is called as complete graph. Complete graph can be denoted by K. So K1 is nothing but the complete graph contains a single vertex. K2 is nothing but the complete graph contains 2 vertices. K3 is nothing but the complete graph contains 3 vertices. K4 is nothing but the complete graph contains 4 vertices. K5 is nothing but the complete graph contains 5 vertices. Suppose this graph is called as K3 graph. So this graph contains 3 vertices. We can take any pair of vertices. These pair of vertices connected by using a direct edge. So we can take a pair A comma C. A comma C is connected by using edge. We can take B comma C. B comma C are connected by using edge. We can take A comma B. A comma B are connected by using a edge. So how many number of colors we are used to color all the vertices of the given graph? That is, so complete graph can be denoted by Kn. So here n is nothing but number of vertices in the complete graph. So for the given graph, we are required n number of colors to color all the vertices of the given graph. Suppose we are considering this graph, it is a K3. How many number of colors we are used to color all the vertices of the given graph? 3 colors. So this is K5. K5, it consists of 5 vertices. How many number of colors we are used to color all the vertices of the given graph? That is n value 5, that is 5 colors are required to color all the vertices of the given graph. Suppose we can see the state map or we can see the country map. So in the country map, the country has some states. So these states are adjacent to each other. So the adjacent states can be represented by using different colors. Suppose we can take India country. In that India country, suppose there are 25 states are there. These 25 states are represented by using some number of colors. We can see the India country map. Okay, any 2 adjacent states does not use the same color. So suppose we can take this example graph. So in this example graph, there are 5 regions are there. First region, second region, third region, fourth region and fifth region. So what are the adjacent regions for vertex 1? So we can take the first region. What are the adjacent regions for region 1? So region 1 is adjacent to region 3. Region 1 is adjacent to region 4. Region 1 is adjacent to region 2. Next, what are the adjacent regions for region 3? So 3 is adjacent to region 1. 3 is adjacent to region 4. 3 is adjacent to region 2. Next, what are the adjacent regions for region 2? 2 is adjacent to region 4, region 5, region 1 and region 3. Next, what are the adjacent regions for region 4? 4 is adjacent to region 2, region 5 and region 3. Okay. So, for this graph, how to represent the planar graph? So, planar graph is nothing but we can draw a graph in a plane with the condition is that no 2 regions are cross each other. No 2 regions are cross each other. So for this graph, this is the equivalent planar graph. So we can take any 2 edges. These 2 edges are not cross each other. So this is the condition we have to follow. Suppose how to draw the planar graph for this given graph. So each and every region can be denoted by a single node. So there are 5 regions are there. So 5 nodes are there. Vertex 1, vertex 2, vertex 3, vertex 4, vertex 5. Next, how to draw the edges between the nodes. If any two regions are adjacent, that two regions are connected by using edge. Suppose region 1 is adjacent to region 2, region 3, region 4. So that is vertex 1 is connected with vertex 2, vertex 3 and vertex 4. Okay, 1 and 2 are adjacent. So then these two regions can be represented by two vertices, and these two regions are adjacent. Then these two regions connected by using a edge. Next, 1 and 3 are adjacent regions. So these two regions connected by using edge. Next, 1 and 4 are adjacent regions. These two regions are connected by using edge. Suppose we can draw this edge in this way. So it can cross the 2 to 3 edge. So we cannot draw that edge in this way. So we can draw the edge in this way. Next, region 2 is adjacent to vertex 4, vertex 5, vertex 3, vertex 1. Region 2 is connected with vertex 1, vertex 3, vertex 4, vertex 5. Next, region 3 is adjacent to region 1, region 2, region 4. Region 1, region 2, region 4. Next, region 4 is adjacent to region 5. So region 4 is adjacent to region 5, and these two regions are connected by using edge. Next, region 4 is adjacent to region 1. These two vertices are connected by using edge. Next, region 3 is adjacent to region 1, region 2, region 4. Region 3 is adjacent to region 1, region 4, region 2. Okay, so for this given map, we can draw the planar graph in this way. Next, suppose we can take a graph. How to find out the minimum number, how to find out all the solutions of the given graph. So all the solutions for the given graph by using M colors that can be represented by using a tree called as state space tree. So here state space tree is used for representing all the solutions for a given graph. So all the solutions can be represented by using a single tree called as state space tree. So in the state space tree, the starting node is called as root node. So suppose we can take a given graph. How to, and M is the minimum number of colors we are used. So for the given graph, what are the possible solutions are there? That solutions can be represented by using a tree called as state space tree. Next, we can go for example problem. How we are representing all the solutions for a given problem. So can be represented using state space tree.